Alright guys, so lesson number 2. Talking about composite functions, pre-cal. Lesson objective with this is to perform operations with functions and iterates, which means to solve. And we need to use functions using real numbers. Okay? Or solve those iterates with real numbers. Verbally, I still need you to describe a function, but this time I wanted you to describe it as it interacts or works in a real-world setting. Be ready in case I question you on that. Alright, your warm-ups, 1 for Monday, 2 for Tuesday, so on and so forth. Remember that, please. Let's jump down here to example number 1. Example number 1, we're given two functions. We're given function f and function g. Now we're going to go through the process first of adding function f and g as it pertains to x. Now this rule tells us that we can rewrite this as the components of f plus the components of g. So that being said, this equals f of x plus g of x. So when we put those two things together, I'm going to come over here and do a, so I've got space. That basically tells me it's my first function, 2x squared plus 5 plus 3x minus 2. That looks pretty easy, right? Combine like terms. The only like terms I have are 5 and negative 2. That's going to become 3. So I'm going to rewrite this for a final answer of 2x squared plus 3x plus 3. Alright, let's check b real quick. B is going to use the same idea. F minus g of x can be rewritten as f of x minus f of g. That being said, we're going to rewrite it the same way we did with a. Go over here and write b down now. So again, 2x squared plus 5, because that's my first part, minus 3x. Now, I've already got a minus 2. What do you think? Should that negative carry all the way through? Absolutely it should. In fact, we'll use parentheses here so that we use this negative as a distributive through the function. So that should rewrite as 2x squared plus 5 minus 3x plus 2. Again, combine like terms, in this case 5 and 7. So our function becomes 2x squared minus 3x plus 7. Alright, and here's where it gets a little bit trickier. F times g, still not really tricky, just a little bit more work. We're going to write that as f of x times, so I'm just going to put the g right next to it, g of x. I can put a multiplication sign if I need to, just for memorization purposes, but f of x times g of x. So rewrite using parentheses this time for c. I'm going to say x, or 2x squared plus 5 in parentheses is going to FOIL against, or factor against, 3x minus 2. I'm sorry, I shouldn't say factor. We're going to find the product of these two separate components. So we're going to FOIL out here, then we're going to FOIL out here. 2x squared times 3x is 6x squared. 5 times 3x is plus 15x. 2x squared times 2 is or negative 2 is negative 4x squared. And then finally 5 times negative 2 is negative 10. Now I need to combine any like terms that I have. In this instance, I don't have any like terms, and I can leave it like this, or I can reorder these two so that I have them in the correct setting. That's supposed to be a cubed right there, not a squared. So that should be 6x cubed minus 4x squared plus 15x minus 10. Alright, let me slide this down and we'll look at finally D. I'm sure I don't need any space for these suckers. Alright. D. F divided by G is the same as saying, hey, that's the function f of x over the function g of x. So when I rewrite this one, I'm just going with 2x squared plus 5 and over the top of 3x minus 2. Look at it both ways. Thankfully or unfortunately, we can't factor this. We can't reduce this. It's set. Okay? So it being set, we're going to leave that as it is and use that as our answer. Alright? Let's move on to example number 2. Example number 2 says we need to write a profit function and then we need to find the profit of 5, 10, and 20. So let's read the question. Business, Madeline pays $40 to rent a booth at a local craft fair so that she can sell silk flower arrangement. It costs her about $25 to make each arrangement she sells. Oh, she sells them for $35 each. So, let's look at it this way. Automatically out of the bucket, she's got to pay $40, right? So that's going to be a negative $40. Now, along with that negative $40 in cost, she's got a negative $25 per object she sells, but her profit is $35 per object. Now let's just combine some like terms here. If I combine these two, I'm going to wind up with 10x. And I'm just going to subtract my remaining cost of $40 from that function. So y, my profit, is a function of x, my cost, along with my initial sales. Alright, so B says find the profit of 10, or 5, 10, and 20. So what it's asking us to do is say, okay, you got 10, figure out what 5 is for x, and that's going to equal 10 bucks. 10 times 5 is 50, 50 times 4, or 50 minus 40 is 10. Next one, it's going to say 10 minus 40. Well, 100 minus 40 is 60. And our last one, 20 times 10. Well, 20 times 10 is 200. 200 minus 40 is 160. Alright? Not too bad. So let's move on to example number 3. Let me slide this back down so we can all see it. Alright, so example number 3. We need to state the domain and the range of each relation. We've already done this once, right? As a matter of fact, Coach Jackson may have and did mess up. I printed the wrong one, guys. It's example 3, 4, 5, and 6 from lesson 1. So we'll cancel this out and we'll go straight to example number 5 for this video. If I need to, I'll come back and put examples 3 and 4 in. Okay, I apologize about that. We'll get that fixed. So, example number 5. Find the first 3 iterates of x1, x2, x3 of the function f of x equals 4x minus 1 for an initial value of x of 0 is equal to 2. Okay, here's how an iterate works. I find out the first one, x of 0 equals 2, so that I take my function, in this case, the 4x minus 1, plug it in, work it out, and I get 7. Now 7 becomes my next iterate. So 7 is equal to x of 1. Alright, so x of 1 is equal to 7, or the final product of this. So now, in order to find the next iterate, I say this. X of 2 is equal to f, the function of x of 1, which is, we just said, 7. So we're going to plug that in. 4 times 7 minus 1. And 4 times 7 is, what is 4 times 7? 4 times 7, I'm losing my mind, I was about to say 14. 4 times 7 is 28. 28 minus 1, I'm losing my mind, is 27. I don't know what's working on with me. So now we're going to find the third iterate, x of 3, by saying that it's a function of x of 2, by saying that the function, or the value of x of 2, was 27. So now it's got to go into our problem. 4 times 27 minus 1. 4 times 27 is 108. 108 minus 1 is 107. And all three of those are solved. How can I can multiply 4 times 27, but I can't multiply 4 times 7? I don't know. I'm losing my stinking mind. Let me check those examples for 3 and 4 real quick, because, yeah, that's what I was thinking. They're pretty important. Let me do this. Let me work one out on here, okay? And I'll get the paper for you, print it out in class. We're going to say that f of g, kind of looks like the word fog, of x when f of x is equal to 3x squared plus 5x minus 1, and where g of x equals 4x plus 5. Now, here's how this works. This says such that basically f of g as a function of x is equal to being a function first of g as replaced by, or I'm sorry, a function of s, a function of f as replaced by the function g of x. Okay? So what that tells me, alright, is that I want to solve f of 4x plus 5. I want to solve 4x plus 5 because this is the same as saying g of x. Now you see how g of x is contained within f? Now where do I plug that into? Well, I plug that into my original function for f of x. So it's going to be 3x squared plus 5x minus 1. Now this x and this x are both going to be replaced by this equation, 4x plus 5. So when I write this out, I'm going to start by saying 3, open parentheses, 4x plus 5, entire thing squared, plus 5 times 4x plus 5, and then minus 1 to finish it off. Now I've got to solve each one of these. I'm going to wind up, for my second problem, distributing here. And here I'm going to have to wind up setting up so that I can FOIL out. So I'm going to start by rewriting this one. 3, open parentheses, 4x plus 5 times 4x plus 5, close. Go ahead and work this out. And that's going to be 20x plus 25 minus 1. So we're going to go ahead and FOIL here. 4x times 4x, 4x times 5, then 5 times 4x, and again 5 times 5. So 4 times 4x is going to give me 16x squared, and then I'm going to get plus 20x a second time, plus 25. Now this is all still contained inside of these parentheses. If I don't contain it inside the parentheses, we're in trouble. Alright? So now I've still got my add 20x on the outside, plus 25 here, minus 1. Go ahead and I'm going to FOIL this all the way through, and I'm going to make a big old mess. Okay, when I do that, I'm going to go ahead and FOIL all of this and combine like terms. Okay, so I can say that's 40x, so the 3 times 40x would give me 120x plus 20x, give me 140. So I'm going to wind up with 140 total x's for regular x. 3 times 16, 48. So 48x squared plus a positive 46. 3 times 25 is 75. 75 plus 25 is 100. 25 minus 1 is 99 positive. So here's my final answer as f of g, or fg of x, when x has this value, g has this value, and we are working our equation such that it looks like this. Now let's flip that around. Instead of fog, let's go with goff. Okay, using these same solution sets, we're going to say g of f as functions of x. Using these same functions that are up here, we're going to rewrite this so that this means g as f of x occurs. So remember, my g problem originally looks like this: g of x plus 5. Now what's going to go in here is not x anymore, because this is the function f of x, and the function f of x was 3x squared plus 5 minus 1. So now inside of this parentheses where that function needs to go. This one's going to be a little bit easier because I only have one thing to replace and then FOIL the number 4 out with. So we're going to rewrite this as 4 as 3x squared plus 5x, I forgot the x right there, minus 1 occurs, plus an additional 5. FOIL, 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 and then we'll combine this term with this term. 4 times 3 is 12x squared. 4 times 5 is 20x. 4 times 1 is a negative 4. Negative 4 plus a positive 5 is a positive 1. And my final answer for g of f as a function of x versus my final answer for f of g as a function of x. Alright, so that was basically what 3 and 4 were about. Not too big a deal. This was example number 3, and I'll tell you what, we'll do example number 4 in class together. I'll do it on the board. It's a little trickier, and I think I would like to see your faces when I show you this information. Sound like a plan? Alright guys, I will see you in the morning.